Sa video natin ngayon, we'll try to solve this problem. Now for the given shear diagram daw, the vertex of the curve is known to be at C, which is right here. Provided that there is no applied moment in the beam, we have to determine the shear 1 meter to the left of B, which is somewhere here. And then we also have to calculate the maximum bending moment in kilonewton meter. Now, let's first discuss the concavity of curves. Now for the shear diagram, since we have y described in terms of x, that we may have this curve or this curve, for which this is the minimum point and this is the maximum point. And so here, since it's mentioned that the vertex of the curve is at C, therefore this is the lowest point of the curve. And so what this means is all of our distances must be measured from this point, all distances along x for ratio and proportion. Now here we have a second degree curve. Now since this is to the second degree, we're gonna use y over x squared for the ratio and proportion. Again, this value right here depends on the degree of the curve. If this is to the third degree, then this will be x cubed, and so on. So what we're gonna do first is we have to draw a line from the vertex up to A. This is so that we can form a spandrel. Using the spandrel, we can apply this ratio and proportion. This is by the squared property of a parabola. And so this is our spandrel. Yan. Now next, we first have to compute this distance, where the shear value becomes 0. And so let's label this as, let's say, x. And so by ratio and proportion, let's first consider this whole spandrel. This one. Now we have A equal to 41.667, and then B is 20.833. So adding both, the height of this whole spandrel will become 41.667 plus 20.833. We have 62.5. So 62.5. Therefore, for the ratio and proportion, we have 62.5. The whole height is to a base of L. Now L is given. It's 5 meters. So this is divided by, again, x squared. We're gonna square the distance along x. So 5 squared equals, we're gonna consider this spandrel. And then the distance of x must be measured from the vertex. You can't use this one. This is a common mistake. So we have here, the height of this spandrel is equivalent to 20.833. And then that's to a base of x. So we have x squared. So solving x, we have 2.886, or let's just say 2.887. Or let's just use 2 decimal places. We have 2.89. So this is now 2.89. And so if this is 2.89, then this distance must be 5 minus 2.89. So we have 2.11. 2.11. Now we have to compute the shear 1 meter to the left of B. Now what is this value in the figure? 1 meter to the left of B is at this point. So this is 1 meter. This is what we are going to solve. Let's say this is y. Now to get this value, we need to still consider the ratio and proportion for the whole spandrel. And so we can actually extend this line. Let's just use another color. So we now have, this is 20.833, and then plus y, that's to a base of 2.89 plus 1 meter. Again, we are essentially considering this spandrel. That one. So again, the base is 2.89 plus 1, this whole distance, and then the height is equivalent to y plus 20.833. Again, y is just measured right here. So this is over 2.89 plus 1 squared equals this value. This is for the whole spandrel. Again, all distances of x must be measured from the vertex. So we have 20.833 plus y. This is our unknown. And then 2.89 plus 1 squared equals 62.5 divided by 5 squared. So we have 16.997. Y equals 16.997. And then this is in Kn. So this is now the shear value at x, 1 meter to the left of B. So our answer will be letter B. Now how about the maximum bending moment? Now for the maximum bending moment, we know that the moment is maximum when the shear is 0. Now here, at this point, here at B, the shear is essentially 0. And so to compute the maximum moment, we need this area, this one. How are we going to compute this area? Let's recall the area of a spandrel. For spandrels, this can be any degree. And then we have base, height, and then the area of a spandrel is actually BH divided by n plus 1. Now this is your base, this is the height, and then this is the degree of the curve. And so to solve to solve this area, total area, then we can use this one. And then we're just going to subtract this area, this rectangular area, and this small spandrel. Now let me just remove this one. So we're going to subtract this. And also this area. We're going to subtract this from the area of this total spandrel. And so our equation will be the area of the whole spandrel minus this pink area, that is the area of the smaller spandrel, and then minus this blue area, that is the area of the rectangle. This is gonna equal this area, the area of the shear diagram. So that will be the maximum moment. So area of for the maximum moment. Now the whole spandrel, for the whole spandrel, we have a base of 5. So 5 and then multiplied by h. Our h is for the whole spandrel 62.5. And then we're gonna divide this by the degree of curve is to the second degree. So meaning n equals 2. So we have 2 plus 1, and then minus the area of the small spandrel, is the base is 2.89. So 2.89 multiplied by the height, which is 20.833. We're going to divide this by 2 plus 1. And then finally, we're going to subtract this area, this blue area. So that's just going to be the area of a rectangle. So minus, this distance is 2.11. So 2.11 minus, multiplied by the height, which is 20.833. And so solving this, we have 5 times 62.5 over 3 minus 2.89 times 20.833 over 2 plus 1, and then minus 2.11 times 20.833. So we have 40.14. So the maximum moment is 40.14 kNm. So our answer is letter A. Now, another way to approach this is you can use integration, and you can use a bit of caltech to model the shear equation. So what you're gonna do is you're gonna go to mode and then press stat. Now, since this is to the second degree, we need to pick quadratic function, or this one, this function containing cx squared. So press 3 and then just disregard the frequency, and then here you're gonna input, for x you're gonna input the distances, and then for y you're gonna input the ordinates of this diagram. Now for second degree curves, we need 3 points. So we're gonna choose at A, that's at 0 meters. Again, x is measured from this point, it's measured from the left. So at x equals 0, the height is 41.667. So 0, 41.667. And then for the second point, we have at x equals 2.11, what we solved earlier, the height is 0 at this particular point, point B. And then finally, at point C, we have the distance is 5 meters, so 5, and then the value of the ordinate is negative 20.833. Now we're gonna use minus because this is below the 0 line. So minus 20.833, press equals, and then AC, press AC, and then shift 1, press 5. So this is for regression. So press 5 and then press 1. We're gonna get 41.667. Now, by the way, the function in the calculator is expressed as a plus bx plus cx squared. So now our the value of a is 41.667. So 41.667, and then plus, we're gonna get b. So shift 1 and then go to regression again, and then press 2. So we have minus 25.04. So let's just change the sign. This is for B, so minus 25.04 and then X. And then finally we have shift stat regression, press C. So C is 2.51 approximately. So plus 2.51, and then x squared. Now this is now our shear equation. Now using this expression, this function, we can directly solve for number 40 and 41. So for number 40, compute the shear 1 meter to the left of B. Now again, x is measured from the left side. So this distance is actually from here up to the point of interest, which is 1 meter to the left of B. This is 2.11 minus 1, which is 1.11. And so using this function, just substitute 1.11 and then you're gonna get 16.9. So we have 41 mode 1 41.667 minus 25.04 x and then plus 2.51 x squared. Let's set this to 0. Press calc, and then x must be 1.11. So we have 16.965, which is letter B. Again, what calc does is it substitutes the value of x that you have inputted. Now for the maximum bending moment, what you have to do is you're gonna integrate the shear equation. So we can integrate this function, and then our limit will be from the origin, which is 0, up to this point, because this is the point where the shear is 0, and so that's also the point where the moment is maximum. So this is from 0 to 2.11. So we have here integral of 0 to 2.11, and then we have 41.667 minus 25.04 multiplied by x plus 2.5 x squared. So press equals, you're gonna get 40.01, which is exactly letter A. Again, this was 16.95. And so this is the better way. Now for situation 5, we have to determine the maximum bending moment. Now here we have a cantilever beam. Now if you have a cantilever beam, then the maximum moment will occur at the support. And so how can we solve this problem? Notice that here we have a function which is 1 over 8 x squared, and then L is 5.5 meters. And so what we can do is we can actually calculate the height at this point using this function. So this is at x equals 5.5. So we have here 1 over 8 times 5.5 squared. So this height is gonna be 3.78125. And then this function is to the second degree. And so what we're gonna do first is let's go back to this figure. Now for spandrels, the centroid measured from the height, this is B over n plus 2. So let's just copy this one. And so here we can now solve the resultant. So this is, we have a resultant right here. And then this is equivalent to the area of a spandrel. Now the base is 5.5 and the height is 3.78125. 3.78125, and then divided by, this is to the second degree, so n plus 1, this becomes 2 plus 1. And so the resultant force will be 5.5 times 3.78125 over 3. So this is 6.93. and this is Kn. Now again, the centroid measured from the height is b over n plus 2. Now the base is 5.5. And so this distance is gonna be, the base is 5.5 over n plus 2. The degree is second degree, so 2 plus 2. So what is 5.5 over 4? 5.5 over 2 plus 2. We have 1.375. So this is 1.375. And so this distance is gonna be 5.5 minus 1.375. So 5.5 minus the answer, we have 4.125. And so taking moments about A, we have a counterclockwise reaction. We also have a vertical reaction and a horizontal reaction. So taking moments about A, we have, as assumed, we have counterclockwise, so minus MA plus 6.93 multiplied by the moment arm, which is 4.125. We can set this to 0. So we have here minus MA plus 6.93 multiplied by 4.125. This is equal to 0. So our maximum moment is 28.58. So MA equals 28.58 586 Kn M. And then since we assume that it is counterclockwise, then this is our direction. And so that's why here we have a negative sign because of counterclockwise. Now determine the bending moment 1.7 meters from the free end. Now here you have to be careful of the question. This is from the free end, not the fixed end. And so from the free end we have 1.7, so this is the free end. This is 1.7. And so we want to calculate the moment at this particular point. And so this is 5.5 minus 1.7. So we have here 3.8. Now by the way, AY is just gonna be 6.93. And this is Kn. And so taking moments about this point, we can actually use integration since we already have the equation, the equation of this curve. So for the moment at this is 3.8 from the fixed end, that's 1.7 from the free end. We have minus 28.586 because this is counterclockwise, and then plus AY, which is 6.93 multiplied by 3.8 meters. By the way, the resultant of this figure is acting downward, and so it will cause a counterclockwise movement about this point. So we're gonna use minus. Now finally, we want the moment caused by this spandrel, but we're gonna cut it right here. And so for the ratio and proportion, we have, this actually has a resultant right here, and so we're gonna solve this height. So for the height, we have 3.78125. This value, the total height of the spandrel, that's to a base of 5.5. But we're gonna square this because this is the degree. And so this is equal to y, which is this value, this height, y over 3.8 squared. So we have y equal to 1.805. Now, another way to get this is just to use y equals 1 over 8x squared and then just substitute 3.8 for x. You will directly get 1.805. And so the area of this spandrel is gonna be, again, BH over n plus 1. Now, the base is 3.8 and then the height is 1.805 divided by n plus 1. So 2 plus 1. Now, this is still the force, the resultant force. We're gonna multiply this by the moment arm going to the cut. And so this is gonna be B over n plus 2. We have 3.8 divided by 2 plus 2. So this is our moment arm. And then adding all of these, we get, this is 2 plus 2. 2 plus 2. Press equals, we have minus 4.42. And then KNM. Or instead of this expression, you can just substitute minus integral from 0 to 3.8. And then you can actually integrate this function to convert it into the shear equation. So we have 1 over 8x squared. Integrating this becomes 3. And then we're gonna multiply 3 right here at the denominator. So this is now 1 over 24x cubed. And so inputting this, we have minus 28.586 plus 6.93 times 3.8 minus integral from 0 to 3.8 and then 1 over 24 x cubed. So we still have minus 4.424. Now, it's not in the choices. Just try to clarify this with your instructor. So this must be minus 4.424. Or I may have committed a mistake. Just try to comment if you can find it.